2, and we are going to be working on dividing multi-digit decimals. Today's lesson is 4.2, and we are going to be working on multiplying multi-digit decimals. So we're going to be going up to the thousands place, or we're going to have 3 decimal places. So the first way we're going to do this is we're going to use this hundreds grid. So remember, every square is out of 100, 100th. So our first problem is to find the product, which is the answer to a multiplication problem when we are multiplying 5/10 by 4/10. So I'm going to pull this up over here, and so we're going to do 5/10. So here's 1/10, 2/10, 3/10, 4/10, 5/10, and I could go the other way as well. And then I'm going to go the other direction and do 4/10. There's 1/10, 2/10, 3/10, and 4/10. So this word, this timesing problem here, this means 5/10 of 4/10. So we have 5/10, and then we took 4/10 going the other direction. So this part where they overlap each other, this is our answer. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 hundredths, or 0.2, or I could even say 0.20, 20 hundredths, 2/10, 20 hundredths. I could even write as a fraction, 2/10. 4 times 5 is 20, but I have 2 decimal places, so I have to move my decimal over 1, 2 places. So you just multiply like normal, and then you need to move your decimal. So when we're finding how many groups of a decimal go into another decimal, we're going to get a smaller piece. We're taking a piece of another decimal. So let's go ahead and look at task 1 here. So we're going to multiply using this grid. So if I want to shade in 5/10, we shade in 5 rows, so 5 columns, which is 50 squares. So we need to shade in 50 squares, because when every time I shade in 1/10, that is 10 squares. So to represent 0.4, 4/10, we'll shade in 4 rows, which is 40 squares. So go ahead and see which grid represents 5/10. So now that we have 5/10 on here, you're going to shade in going across 4/10 to show the overlapping part, which is 5/10 of 4/10. So you can see this overlapping piece here means that there are 20 squares shaded in. So the double shaded squares represent the decimal 20 hundredths. So when I do 0.5, 5/10 times 4/10, we get 20 hundredths, or I can take away this last 0, 2/10. So that's one way, is you can draw yourself a grid. Now, when we're getting up to numbers like 457 and 78 hundredths, maybe we don't want to draw a picture of that. So let's look at another strategy we could use. So we have that Kara's buying 11.2 pounds of pork for $3.50 per pound. So every time she buys a pound, it's $3.50. She buys 2 pounds, there's another $3.50. 3 pounds, another $3.50. So we're repeatedly adding. So we know we want to multiply to find this answer. So we're going to use this area model here to help us solve this problem. So what we did is we took 11.2, we just gave every digit its own box, and we're timesing it by $3.50. We don't need that final zero, because whether I have $3.50 or $3.50, I have $3, 5 dimes, no pennies. So we don't need to do that final zero. We can make our work a little simpler. So what we do is we take every column and every row and multiply them together. So I take 3 times 1, and this is really, I like to write it in expanded form actually. So I like to say that this is really 10 plus 1 is $11.20. So I like to use that expanded form there. That helps me remember that I'm not just doing 3 times 1. This is actually 10 times 3. So 10 times 3 is 30. And then I'm going to do 3 times 1 is 3. Now I'm doing 3 times 0.2. So 3 times 2 is 6, but I have 1 decimal place. So this was 3 times 2 is 6, but there's 1 decimal place. So I move over 1 place, 0.6. And then we're going to add these up. So 30 plus 3 plus 0.6 is 33.6. So now we come to our next row, and I'm going to do 10 times 0.5. So just think of it like 5 for now. So 10 times 5 is 50, but I have 1 decimal place, so I move it over 1 place. So 5. And now we are going to do 1 times 0.5. So 1 times 5 is 5, but I have 1 decimal place, so we moved it over. So there's 0.5. And now we have 2 times 5. 2 times 5 is 10, but I have 2 decimal places. 1, 2. So here's 5 plus 0.5 makes it 5.5 plus 10 cents more is 5.6. So now we are going to line our decimals up and add these together. So 6 plus 6 is 12. 5, 6, 7, 8, 9. And 3 more. My decimal goes straight down. You can even add the 0 on. So to get 11.2 pounds of meat, she will spend $39.20. So I like to write it out in expanded form, and you multiply the top by the bottom or the side number, every single one, add up your boxes across, add up your boxes across, put your 2 partial products together to get your final answer. So let's look at task 2 here. So we know we needed to multiply. So 3 times 2 is 6 with 1 decimal place. 1 times 5 is 5 with 1 decimal place. Sorry, this is 10. So that's why I like to put that 0 there. So this is 10. 10 times 5 with 1 decimal place is 5. 2 times 5 is 10 with 2 decimal places. So see if you can fill those out. Then we add those together. What do we get? So how much will they pay total? So when we put these labels out up above and out to the side on your turn and talk, you're going to tell me, where did those numbers come from? How do you know what to put above each box? Hey, task 3, we have Jared mowing the grass every summer in the weekend. I'm going to come over to this page here. And the amount of gas he uses every hour is 1.2 liters. So how much gas will he use in 5.8 hours? So every hour he uses 1.2, the second hour 1.2. So we have to do that 5.8 times. We're just going to try using the standard algorithm here. So I just stack my numbers on top of each other. I like to put the easier one on the bottom, and I think 1 and 2 are easier to multiply by than 5 and 8. So it doesn't necessarily have to be the bigger one. I just like to put the easier one that I know better on the bottom. Your decimals, in this case, they are lined up, but they do not have to be. So I start here, 2 times 8 is 16. I come and do the 2 times the 5 is 10, plus 1 more is 11. So for right now, I'm just ignoring my decimals and pretending like they are not there. So now I think it's helpful to cross this number out or erase it so I don't get confused and accidentally use that again. So one of the most important parts of multiplying by double digits is to get this placeholder 0, because we're no longer multiplying by this first place. We bumped it over a place. So 1 times 8 is 8. 1 times 5 is 5. So that's why I like to cross that out so I don't accidentally add it if I don't need it. Now I add my partial products together. 6 plus 0 is 6. 8 plus 1 is 9. 5 plus 1 is 6. Now I like to come up and circle my decimal places. I have 1, 2 decimal places. That means I need to move my decimal over 1, 2 places to the left. So in 5.8 hours, they would use 6 and 96 hundredths gallons of gasoline. So almost 7 gallons of gas. So let's go ahead and look at task 3 here. So we know we were doing repeated addition, so we had to multiply. So if I were rounding these, 5, look behind the 5 is an 8. 8 is a bigger number. It's going to bump the 5 up to 6. And 2 is not strong enough to bump the 1 up, so it's going to stay 1. So 6 times 1 is 6. So my answer should be about 6 liters. So now we are going to explain. So we know the product of 58 and 12. So if I do that, the product of 58 times 12, so I ignore those decimals, is 696. And then I have 1 decimal place here, and I have 1 decimal place here. So that means I have a total of 2 decimal places that I need to move my decimal over. So the product of 5.8 and 1.2 was 6.96. So very close to 6, our estimate. Because the factors 5.8 and 1.2 have a total of how many decimal places are in 5 and 8 tenths and 1 and 2 tenths, we had to move the decimal how many places. So what was our estimate? My estimate of 6 is close to the product of 6.96, so my answer is reasonable. It's always important to think if your answer is reasonable. The other day, I was doing a math problem, and I needed to be multiplying, and I was dividing. And I knew that my answer needed to be bigger because I had read the problem, and it told me that this one was farther away, so I knew it needed to be bigger. But I wasn't using the right operation, and I kept getting a smaller answer, and I knew it didn't make sense. So I knew I needed to try again. So if you were getting an answer of 0.6, well, that's not very close to 6. If somebody owed me $6 and they said, here's 60 cents, that's not the same thing, okay? So you've got to stop and think about, does my answer make sense? So we are going to try just a couple more problems here. So we're going to do one with the area model, and we're going to do one just with a standard algorithm. So we're going to try this area model first. So I have 5 ones, and I have 7 tenths, and I have 8 hundredths. So you're just telling me how much is in each of those places. So I'm going to split it up for each decimal or each place. And then on this one, I have 3 tenths, and I have 4 hundredths. So now we just match everything up. So 5 times 3 is 15 with 1 decimal place, so 1.5. 7 times 3 is 21. Got 1, 2 decimal places, 1, 2. And then I have 8 times 3 is 24 with 1, 2, 3 decimal places, 1, 2, 3. So I need to add a 0 in here to make it have 3 decimal places to the thousandths place. So now we're going to do I'm going to stop and add those up. So I had 1.5, 0.21, and 0.024. So 4 plus nothing. I'm going to fill in these placeholders. So 4 plus 0 is 4. 2 plus 1 is 3. 5 and 2 is 7. And 1. So this part here is 1.3741 and 734 thousandths. So now I'm going to do 5 times 4 is 20 with 1, 2 decimal places. 1, 2. 7 times 4 is 28 with 1, 2, 3 decimal places. 1, 2, 3. So I need another 0 here. And now I have 4 times 8 is 32. And I have 1, 2, 3, 4 decimal places. 1, 2, 3, 4 decimal places. So I'm going to fill those in with zeros. So I need to add up 20 hundredths and 28 thousandths and 0.0032. I'm going to fill these in just to remind myself there's nothing there. So there's 2, 11, 3, and 2. So now I can add both of my pieces up. 2, 3, 1, 2. So put my placeholder here. So here's 2 10 thousandths, 5 thousandths, 6 hundredths, 9 tenths, 0.1, and 9,652 10 thousandths. So let's go ahead and try the standard algorithm. So I like this way because it makes it so that I can do it in my head a little bit easier. I don't have to keep track of everything as much. I can just do one little piece at a time, and it makes sure I get every number multiplied by every other one in the other part of the problem here. But let's try it just using the standard algorithm. So 5.78, I'm putting 34 hundredths on the bottom because it's a smaller number, so that will make it easier. So I do everything times the 4. So 4 times 8 is 32. 4 times 7 is 28, 29, 30, 31. So carry the 3. 4 times 5 is 20, plus 3 is 23. So now remember, we want to cross these off because we are done with them. And I'm going to put my placeholder 0, very important because I'm multiplying by the next number. So 3 times 8 is 24. 3 times 7 is 21, plus 2 is 23. So that's helpful that we crossed out those other numbers so we didn't accidentally add the wrong one. And 3 times 5 is 15, plus 2 is 17. So we end up with 2, 5, 6, 9, 1. And I have 1, 2, 3, 4 decimal places. 1, 2, 3, 4 decimal places. 1, 9, 6, 5, 2. So if you notice here, this is the same and this is the same. So we're getting the same answer. So you are welcome to use whichever strategy you feel like you understand the best and like. So I often do this because I've been practicing multiplication for a long time. But if it helps you to break it up, or if you would like me to practice that more with you, just let me know and I would be happy to do that. So you guys are going to work on your check for understanding and your practice and homework. Let me know if there's anything I can do to help you.